Good morning, students. Today we are going to discuss about module number 2, that is network theorems. Here we are going to discuss about that reciprocity theorem and problems on reciprocity theorem. As we know that reciprocity theorem, and if you see about the statement of reciprocity theorem. Reciprocity theorem states that in any two-terminal linear bilateral network consists of a single voltage source at the terminals A dash. You produce a current response at terminals B dash. If we interchange that source and load positions, that means at terminal B dash, if we place that a voltage source and it produces a current at terminals A dash, then the ratio of response to excitation is same even though source and load positions has been interchanged. Then the reciprocity principle is verified. To meet that reciprocity theorem, the following conditions has to be met for the application of reciprocity theorem. What are the conditions which has to be fulfilled to apply the reciprocity theorem means? The first one is the circuit must have a single source. If it is applicable only for the circuit which has that only single source, it is not applicable for the circuits where it has that multiple sources. And initial conditions are assumed, that is absent in the circuit. That is initial currents, initial voltages has to be absent, otherwise this principle is not verified. The next one is dependent sources are excluded even if they are linear. So dependent sources are excluded even if they are linear. When the positions of source and response are interchanged, their direction should be marked same as in the original circuit. Their directions means, that is the direction of flow of current has to be marked like in the original circuit while we are applying the reciprocity theorem. So these are the following conditions what has to be fulfilled to the apply of reciprocity theorem for any given case. Let us see that how we can verify the reciprocity theorem. Reciprocity property can be verified only for linear and bilateral networks, and it is not applicable for nonlinear circuits. So to discuss and to get that proof of the reciprocity theorem, let us consider a problem, that is verify the reciprocity theorem in the figure 1. So if you see that here I am considered a problem, that is this problem consists of only one voltage source, that is 10 volts voltage source, which is placed at the terminals X and Y. And I am going to consider that the load element is nothing but 2 ohms resistor which is connected at the terminals A and B. So from this problem here, if you see or if you check that reciprocity principle, that is here according to the statement of reciprocity theorem. So it is a two-terminal linear bilateral network which consists of only one independent voltage source which is located at the terminals X and Y. So voltage source, 10 volts voltage source is located at the terminals X and Y, and the load element, that is 2 ohms resistor, which is located or placed at the terminals A and B. So due to this 10 volts voltage source, it produces a current response, for example I in the 2 ohm resistor. Then now to verify the reciprocity principle, now we have to interchange that source and load positions. What is the source and load here? The source is 10 volts voltage source and the load is 2 ohms resistor. Now I want to replace. Means I need to remove this 10 volts voltage source from this position and I have to connect in series with this 2 ohm resistor here. This is the plus and minus terminals. And here I want to short that I want to short this 10 volts voltage source by considering the internal resistance at the XY terminals. Now again we produce that one current here with this 10 volts voltage source. Now the current I, whatever it produces, it should be same for the previous case. Then the ratio of response to excitation, that is I by V at case 1, I by V at case 2, if it is same, then the theorem is verified. So this kind of reciprocity principle we are used in the telephone systems, in telephone applications. Let us see that solution. So with reference to this figure, I am going to calculate the current I at the terminals A and B. The current in this 2 ohms resistor I am going to consider it as I2. I2 is equal the current. If I want to find out the current I2 here, means before that I want to find out that that is the total current I1 which is driven by this 10 volts voltage source. How to find out that I1 here, means I1 is nothing but the total current which is driven by this 10 volt voltage source. Therefore I1 is equal to V divided by R equivalent. Here V is nothing but 10, but what is R equivalent here, that is the question. So let us find out the value of R equivalent. To find out the value of R equivalent means analyze the currents in the given circuit according to the circuit what they given for us in the figure 1. Here I1 is the total current which is driven by this 10 volts voltage source, and I1 is again divided into two currents. One is I2, one is I3. So I2 is the current commonly which is flowing through 1 ohm resistor and 2 ohm resistor. Therefore 1 and 2 are in series, that is 3 ohms. So now 3 ohms branch is connected in parallel with again 3 ohms at here. Therefore the R equivalent is equal here. The R equivalent value here, it becomes 3 is parallel with 3 plus 2. 2 is this ohms. So this is the R equivalent value. Let us find out that R equivalent value. So R equivalent value is equal 2 plus 1, that is 3 is parallel with 3 and plus 2. So if you solve this one, 3 is parallel with 3 means 3 into 3 divided by 3 plus 3. 3 into 3 divided by 3 plus 3 plus 2, 9 by 6 plus 2. 9 by 6 plus 2 means it becomes 3.5 ohms, that is 3.5 ohms R equivalent value. Now find out that I1. I1 is equal V by R equivalent. V means here 10 divided by 3.5, it becomes 2.86 amperes. Now I know that I1, but I need to find out the response in the terminals AB. I want to find out the response in the terminals AB, means here the response is I2. So find out I2. How to find out I2 here? The value of I2 here we can find out by applying the current division rule. So how to apply the current division rule here? I want to find out the current I2. I2 is equal, what is the formula? I2 is equal total current I1 into opposite branch resistance divided by total resistance. So I1 means just now we are calculated, that is the total current here, and opposite branch. For this branch, what is the opposite branch means this 3 ohms. Total resistance means 3 plus 3. So use this formula and get the solution. So now here I am calculating that I mean I3, I got I3 is equal 1.43 amperes. Two ways are there to find out that I3. One is, if we know that I1, then next we have to calculate I2. I2 here 1.43 amperes. If I2 is equal 1.43, then I3 is also 1.43 amperes. Next, now according to the principle of reciprocity theorem, now we have to interchange that source and load positions. So the circuit which has been shown in this figure 2, that is here, we are short circuited that voltage source 10 volts at here, and we are placed that 10 volts voltage source in series with this 2 ohms resistor. Now our ultimate aim is to find out that current which is flowing in the XY terminals. The current flowing in the XY terminals, now I can call it as I1, For suppose here I2 is the total current which is driven by this 10 volts voltage source, and again it is divided into two currents. One current which is flowing in this branch called as I1, another current which is flowing in this branch called as I3. Our ultimate aim is to find out I1. What is the value of I1 here? The value of I1 here it is, the value of I1 here it is total current I2 into opposite branch 3 divided by total resistance 3 plus 2. So we need to find out the total current called I2 here. What is I2? The value of I2 here is equal total current which is driven by this 10 volts voltage source, that is I2. I2 is equal here total voltage V divided by R equivalent value. What is V? V is 10 volts. Then what is R equivalent value? Question. To find out the value of R equivalent value, how to find out the R equivalent value here? The value of R equivalent value here according to the given currents in figure 2, we can find out that R equivalent value. So if you see here, 2 ohms and 3 ohms are connected in parallel because those currents in those branches it is different. Here it is I1 and here it is I3. So these two are in parallel, and again it is series with 1 ohm. Therefore 2 is parallel with 3, again it is plus 1. Then it becomes 2 into 3 divided by 2 plus 3 plus 1. That means 6 by 5 plus 1. 6 by 5 plus 1, and again here 2 na. So 6 by 5 plus 3. 6 by 5 plus 3, and it is equal to 21 by 5. It is almost equal to 4.2 ohms. Now we got that R equivalent is equal 4.2 ohms. Let us find out that what is I2. I2 is equal to 10 divided by 4.2 here. If it is 10 divided by 4.2 I2, it becomes 2.831 amperes. Now if I2 is equal 2.381 amperes, 2.381 amperes I2, then find out that I1. How to find out? By using that current division rule. By using current division rule, if I want to calculate that I1 is equal I2 total current into opposite resistance 3 divided by total resistance 3 plus 2. That means I1 is here 2.381 into 3 by 5, it becomes 1.43 amperes. If you see that the response in AB terminals now it is 1.43 amperes in case 2. The same value has been repeated in case 1 also, that is also 1.43 amperes. Therefore the response at both cases it has been same. Therefore the ratio of response to excitation I by V value at case 1 and case 2 is same. Hence it proves that reciprocity principle or bilateral property principle. Thank you.